So this is our function for moving the turtle to desired point. I had initialized the node turtlebot controller. We have the publisher for publishing the velocity and the subscriber for subscribing for the pose of the turtlebot in the plane of the turtle sim simulator. Now we are initially taking input of the desired coordinate as from the user, and then we are calling a function rotate towards the point. So let us go to that function. So this is that function. What this function is actually doing is um, we have subscribed to the pose of the turtlebot. So this is a while loop that is running continuously. So we are subscribing to the current pose, and in each iteration we are calculating this angle to target. This is the angle which we are calculating with the help of inverse of tangent using math library of Python. So what it is actually doing is whenever the turtle rotate in each iteration, it will calculate how much rotation or the change in the angle is left, and accordingly it will give the angular velocity to it. So it is direct, the velocity of rotation of turtle is directly proportional to the amount of angle left to be rotated by the turtle bot. But here is the point change in that I am taking the max angular velocity to be 1 here to work the turtle in accordance with the accuracy of the rotation action. So whenever the angular velocity exceeds the maximum angular velocity, I'll equate it to maximum angular velocity. So now this is the basic command for publishing the angular velocity. Now if the angular well if if the angle to target and the desired target is smaller than 0.01, then this loop will break, and we'll consider that as our final destination. Now this 0.01 is the accuracy of this function for rotating the turtle sim bot. Now we are calling self.move function. So it will take the target x and y and the current x and y, and we'll go to this function here. Okay, so now what it is doing initially, it is calculating this distance, that is the distance between the target point and the current point. We are giving speed is equal to 2 in the whole process, and we are subscribing to the current time at this point of whenever the function is called, we call that time t. And there is also one more variable, current distance, which keeps the track of the distance traveled by the bot while traveling. So now we are in the loop. So in the loop will run with the if condition. Whenever the current distance traveled is greater than the required distance, this loop will break. But before breaking, it will publish a final velocity message of doing the velocity 0, so that it immediately stop at that point. So here what is happening is we are publishing velocity, that is speed in the x direction only, that is to y in the x direction, because we have already rotated the turtle in the desired angle, so that the face of the turtle point towards our destination point. And tc, that is our current time. uh, this is the initial time and this is the current time, and we know the speed. So using the basic formula of the distance traveled, we can find the distance traveled by the bot. So now here we are publishing the velocity. Now uh, we are also printing the velocity and time with it, and we are giving a rate of sleep of 100 hertz. So in every 1 second it is publishing 100 messages. So by this we can calculate its accuracy to be 0.02, and whenever this condition will hit, it will stop. As described in my report, in the previous or in my first attempt, I created this function that was not working properly. What it was doing, it was not rotating the turtle in the desired pose. It was just doing a crab walk of the bot of the turtle bot, and it was moving towards the desired point without rotating. The major problem with this was many of time with certain Cartesian points, it was reaching the final point, but also then the velocity was increasing and it was running forward without stopping at the final destination. So I dropped the idea of using this function. Then I created these function. So for this, thank you.